Speaker view, gallery, full screen. Okay. I'm going to go to full screen first. And then I'm going to see how many people have come in. 30 people have come in. I'm counting how many people are coming in and to your session. So you also get a count, general count, when I'm looking at it. Okay, there are 3 minutes. I'm going to start introducing you so that you get enough time. And before that, I want to welcome the speakers and the attendees who are dropping in more and more. We already had a session from 8 to 9:30 from Joel Lowy on artificial agility, and some of you may have attended. And now we have another great speaker, Sriram Subramanian. And for you to know that we have been doing these conferences for many years. We have done about 25 plus conferences. The last AI conference we did, Global AI, was in January 21, 22, and 23 in Santa Clara Convention Center. And because of the grace from COVID, we are going to be doing live on the Zoom here over the web. And so you don't have to travel. That's the advantage. And all the 3 days we have sessions going on, we have panels going on, we have finance track and different tracks that will be going on. So that will be the things that we are going to cover. And as well, in terms of we are doing a startup competition every time we do a conference. I happen to moderate the startup competitions, and we have invited judges. That will be tomorrow if people want to attend, and if you are in the competition lined up, be ready to do that. All the instructions have been sent to you and the judges, and I'll be moderating that as well. And let us know if you have any questions. You can go to the Q&A part of it and input your questions for the speakers for the whole day, if you are going to be there, or at least for this speaker for the first time that we will be doing. And I'm going to be going to his profile and do a quick introduction about Sriram. Okay, hold on. Okay. He is a research director at IDC. For people who may not know what IDC is, it's a company which does in multiple verticals, multiple areas, subject areas, analysis on a contract basis with companies, as well as in general that they present. And I know many of the directors over the past decades from IDC, who are my friends who are in the industry, like probably Sriram, who has gone into that. That's a very valuable service that they provide. I'm very happy. And he has few areas that he's involved in. And the areas are, there are 3 areas. One of them is infrastructure systems, platforms, and technologies group, ISPTG as abbreviated. And he covers the following areas: infrastructure for enterprise workloads, operating systems and environments, and artificial intelligence for enterprise workloads. He, being an expert in these areas, he will have given topics, lectures, and talks. A lot of times they sit at the marketing panels, etc., to talk or present their findings for everyone. And today he's going to be speaking for half an hour. And please take over, Mr. Sriram Subramanian.
Thank you, Murthy. Thank you all. Good morning, good afternoon, wherever you're from. Thank you for joining today. I will start. Murthy, can you please allow me to share the screen?
Oh, okay. Hold on. Let me see where I go and do that part. View. Speakers view. Hold on. screen.
Yes, Sriram, can you try now? I enabled the...
Yeah.
I'm able to do that. Thank you, Lynn.
Yeah, share screen. Yeah.
Are you all able to see my screen?
Yeah, we can see it.
Thank you. Before I want to get started, I hope everybody is doing healthy and safe in this crazy environments. Thank you for joining us today. My name is Sriram Subramanian. As smoothly introduced, I'm a research director with IDC. My primary areas of coverage are enterprise workloads, operating systems, and AI-enabled workloads. Today, I'll be talking about how do we consume AI and ML technologies. Most of you here, if you're attending this talk, you probably have heard about AI, ML, and you probably are already consuming it, using it, having some challenges in how do we make your experience better using AI and ML technologies. This talk will give you some insights into, compares how do we consume AI and ML technologies with relation to how we have been consuming infrastructure. And based on that comparison, give some recommendations on how do we go about. It also introduces, the concept of AI plane. Think about how do we have your infrastructure stack to support your AI and ML workloads. And at the end of it, you will see some recommendations. The take home is, if you have a business use case and if you want to leverage AI and ML technology, what is the right option for you? What is the right consumption model for you? What is the right infrastructure stack to support that? All these things will be discussed in this talk. This is the short agenda. I'll start with what is the current AI adoption looks like. I will walk you through what happened with cloud, what happened with infrastructure consumption models. I will give an overview of that and then apply the same model for consuming AI and ML technologies. After that, we will discuss all those things that we listed before, right? What is it? What is an AI workload? What is the right infrastructure stack for that? What are the options available? Finally, ending up with some solid recommendations. If you have done any online shopping now, if you have done anything with your app, most likely it has been enabled or enhanced through AI and ML technologies. We have seen in the past few years a Cambrian explosion kind of adoption of AI and ML technologies, artificial intelligence and machine learning technologies in the consumer space. Whether it is your shopping recommendations or your autonomous vehicle or conversation assistant, you use your voice enable assistants, natural language processing, all those things are possible because of the innovations in the AI and ML technologies in the recent few years. What is more interesting, what we are talking about, what we're going to discuss more about is not about the consumer side of AI and ML adoption, but more about enterprise side of things. One IDC study forecasts that the global AI market is to grow about $98 billion by 2023. All these things are, portraying everything AI is done, AI can do everything, AI can make anything possible. But we have to be realistic here, and we're going to focus on how can enterprises get benefited by these technologies and innovations. So based on our various surveys and conversations, the use cases differ, but some of the popular use cases across multiple verticals, whether it's retail or healthcare or gov or whatnot, some of the top use cases that come across based on our conversation surveys are including IT operations, customer service and support, and fraud or risk management. These use cases vary, but you can see that where enterprises are lining up, right? Typically, what they are looking at is how can they make these kind of business use cases better using AI and ML technologies. Now, when I say that they're using AI and ML technologies, as we will see, it could be from building up from ground up, building up your entire AI infrastructure, AI models, your ML models, building them, training them, or they're also leveraging the applications and workflows and workloads enabled by AI. For example, if you're using a workforce management in your day-to-day operations, day-to-day business cases, you may not have infused or enabled an AI capability into that, but the vendor offering the WFM capability may have already enabled or leveraged AI ML technologies to make your use case better. Having said that, we have seen a rosy picture so far. You're seeing that, okay, AI can solve everything, kind of people are going with that. But is it really the case? We also observed that enterprises are facing adoption challenges, very similar to what we faced with adoption challenges with cloud computing. some of the key challenges that come up in conversations over and over is lack of skill set, lack of clarity, and the lack of an enterprise-wide AI strategy. What does lack of skill set mean? If you have built, or if you have tried building, or if you have used AI or ML, you may notice that, or you would have observed that it involves a very strong data science experience. Data, how to make sense of it, what kind of data to use, how do I build models, how do I train my models, and what does inference mean? All those things are hard problems, and it's a new skill set to develop, to acquire. Something that we find is enterprises, they have deep subject matter expertise, but they don't have data science expertise. And you see data science folks, they have a very good, very solid understanding of what to make sense out of data, but they lack the subject matter expertise. So some kind of bridging or marrying these two is required. And that's typically a very, very a key challenge that enterprises face. What does lack of clarity mean? Lack of clarity refers to, like, what do I start with? Where do I start with? Do I need to build from upfront? Do I need to build my, do I need to, like, what do I do with my data? How do I prune my data? How do I sanitize my data? How do I build my model? How do I train my model? Like every step that's involved in what we call as AI pipeline, there's a set of confusions. Then comes into this, like, where do I run this? What kind of infrastructure do I need? Do I run it on premises? Do I go to a cloud service provider? Or do I get help? You know, all those things are not very clear. And another aspect of this lack of clarity is, I have a business use case, I have an application. Now, do I rewrite the application? Or can I consume something equivalent, which is already enhanced with AI and ML workload or AI ML capabilities? So all these kind of things come under lack of clarity. And as with what we saw as early stages of adoption of cloud computing, enterprises still are, a vast majority of enterprises are still in that bucket of not having enough skill set, not having enough clarity. Of course, there are always outliers. There are always, like, technically mature enterprises. We're making huge strides. They are innovating ahead. They are paving the path for others. But we're talking about the vast majority of enterprises who are on the left side of the adoption curve, and we will focus on how do we help them. And one study pointed out that, you know, about 50% of respondents said that they saw some kind of failure with their AI experiment or AI adoption. And they cited that not having an enterprise-wide AI strategy was one of the reasons for such failure. A group might be doing something cool, but the other groups may not be able to adopt it. Or, you know, they might be using some kind of technology, some kind of platforms which are not suitable for other groups. So these kind of challenges that enterprises face. Now we will, as we go with the talk, we will see some kind of recommendations on how do we overcome these challenges. If you have any questions, like, you know, the moderators will handle that. Please feel free to queue it up or wait until the end of the QA session. I'll be happy to go over any of these. As I mentioned, I was making comparison with the adoption of AI and ML and the AI ML ecosystem with how the cloud computing evolved. You know, if you have been following the cloud computing space, which most of you would have been, you know, you can see that the infrastructure consumption has, the way that enterprises consume their IT infrastructure has changed significantly. We will use this consumption model as our guideline, and we'll try to apply this model to how do we consume AI and ML technologies. Enterprises typically have some kind of on-premises investments, right? Either within their own premises or with co-located. Why do they have it? Because, you know, that's how they've been always doing it. But this invites upfront investments, right? But they have full control here. They build, manage, deploy, operate, whatever they want to do, they do it. Typically, these environments are bare metal servers or virtualized servers with some kind of container adoption happening in the last few years. But essentially, like, no, these act as the central shop. Typically an IT admin or a group of IT admins manage this, and they provide as the infrastructure sources for other groups within the organization. If a developer wants a server or a VM, they raise a ticket, and depending on how robust the automation is or the processes are, the developer gets the VM, the resource they requested within hours or even within few days. And typically when there is a requirement for scale coming up, they go by scaling up. Instead of like 2 CPU VM, they might give you like 4 CPU VM. Instead of 4 GB RAM, they'll ask you to go to 8 GB RAM or 16 GB RAM. An application with the larger scale requirements, they typically scale up the resources so that they can handle the scale requirement. As you can notice that this involves a tremendous amount of management overhead. Day 2 operations, day 0, day 1, day 2, all the operations are managed by the IT admins, and it needs a level of expertise that, a very hardcore operational expertise to run it smoothly in case of downtime, in case of outage. How do we troubleshoot? All those things are at the hand of the enterprises. However, enterprises who want a full control, for example, they want to be able to say, okay, we will own it up. We want to have absolute control on what is running on our end. They prefer this model. With the advent of cloud, what happened was now a developer can just spin up a VM as they require. They don't need to have any upfront investments. All they need is a credit card, and they will only pay for the amount of duration they use their VM or the virtual resource. And then that's all, they're done. And this helped developers to move faster. Instead of raising a ticket to the IT admin asking for a VM, they could just request it from a cloud service provider. It's done instantaneously or almost instantaneously. They use it as long as they want it, and they're getting it done, right? This was commonly referred to as shadow IT. Here, the management of the underlying infrastructure, the servers that are running these VMs, they are managed by the cloud service provider. Just the VM or the virtual database, whatever the developer or the end user is consuming, only their lifetime they have to manage the creating a VM, CRUD operations on them. They don't care about the underlying infrastructure. And in case of scale requirement, they go by scaling out. They go horizontally. Instead of adding more and more RAM and more CPUs, they would just require another VM and another VM. Of course, I'm simplifying it here. Clustering and high availability, all those things are a little bit more complicated than this. But the essence is on-prem traditional data centers, you scale up vertically. With cloud, you are able to scale horizontally. As you can notice here, the management overhead is significantly cut down. Imagine an enterprise moving from on-prem to IaaS model. Now their management overhead is cut down more than 50%, right? They don't have to worry about the uptime of the servers. They don't have to worry about patching the servers. They do have to worry about their virtual resources, which they will continue to manage. But as you can see, IaaS provides them an additional, takes them off from management overhead already. Then comes the layer of platform as a service, where you don't even have to manage your virtual resources. You talk in terms of applications. You need to run a web server. Don't need to create a VM, install IaaS or Apache web server. You can just request for a web server app. And so it follows the same scale out model. The underlying infrastructure is still managed by a service provider. Now the developer can focus only on the app. So you can see that already with this infrastructure abstraction, the management overhead is going down and down. Then comes the case of managed IaaS, which is, it varies between service providers. The definition of the managed IaaS and IaaS is blurring out with more and more services being called. But the key distinction is, imagine a past level of, I don't even have to worry about my VMs, but I still have the abstraction of VMs. I still can run the application the way that I was running on premises without managing anything, right? That is what the managed IaaS provides. The key distinction is, say, for example, if you have an app where there's no PaaS equivalent of that, you still have to run it on a VM. But if you don't want to run the VM, then you can get help from managed IaaS services, where your infrastructure and the virtual infrastructure, they both are being managed by somebody else. You only focus on running your application. Now, this is approximately like what we're trying to say is, as you can see, as the abstraction goes higher and higher, the management overhead goes lower and lower. The control, you can see on the extreme, on premises, you have full control. You have full visibility on what's going on. But there are cases where you may not require that. And when you don't require that, you go kind of to the right side of the spectrum. We will try to use the same model to see how we apply the same model in how do we consume AI and ML. And depending on your business use case, depending on your skills or expertise, you can pick one or more, depending on what the case may be. When it comes to A and ML, roughly speaking, right? Like, what do you need? You have a business use case. You want to make something better. You want to enhance it. You want to get more accuracy. You start with that. Now, having said that, or you want to enable an entirely new use case, an entirely new capability, voice recognition, for example, right? It may be new for you, but not exactly in the industry. So what do? So you start with, okay, what are the options available for me? Okay, there is this cool technology. I can make my accuracy a lot better through machine learning. Okay, I'll start building my models. So what do I do with, what can I start with? Okay, what are the options available for me? Oh, there is open source AI platforms available. Maybe I can start with it. What does a model mean? What does building a model mean? What does training mean? You go through all these things and you can see like there's a lot of decisions to make regarding this software platforms, software tools to use, where to run them, how do we run them? But all those things kind of fall similar to what the on-prem model was. You have the full control, but you're building everything from scratch. But which means that you're going to have a lot more expertise requirements, a lot more overhead to get your returns, to get your final, your immediate outcome. You may have to have a long upfront investment. But there are cases you may need to do that. There are possibilities, there are ways, and there could be some stringent requirements for doing that. But typically what we find is enterprises who are trying to explore into this, they start from there, which is very hard, which is very discouraging to begin with, because they are not very clear and your KPIs may not be very clear. And you are more prone to see failures, right? Because key thing is they may not have the data science experience. Now comes this second level of AI or ML as a service. It's very similar to the IIS capabilities. Almost all cloud service providers provide some kind of machine learning capabilities as a service. Here, you can imagine similar to consuming a VM. You still are going to manage the VM. You still are going to develop your application, but the VM where it runs, it's not in your, it's in the cloud service provider. Similarly, your machine learning, you still have to build the algorithm, but where it runs, the machine learning model where it is deployed, the resources to do that one, they are managed by the cloud service providers. Azure ML, Amazon ML, IBM Watson ML, all these are good examples of that. Please note again here, you are still building, training, and inferring the models. However, the key difference here is that the TensorFlow or whatever platform that you are using, you are not managing that. You are not deploying, managing that. An ability to run your model, build your model is provided by the cloud service provider itself. Then comes the equivalent of PaaS, where we call as AI ML platform as a service. Here, even the infrastructure management is taken away from you. And of course, there's some of the platforms provide you even better capabilities. They help you with building the model itself. You don't code the model. You probably there's an easy way to upload your data, and then they will give you a model built for you. But the essence here is that you are moved away from managing the platform. You don't have to worry about running, installing, managing TensorFlow. You are not building your model. You are just letting the platform build one for you. You can consume the model. Google AutoML is a great example of that. And this is very similar to what the PaaS capabilities we saw before. Then comes to the next two levels. You can see the manage AI ML as a service is very similar to the manage IIS. Here, the platform provides the models for you. There are some pre-built model available. You just pick and choose. You still have to optimize it. But where you are running it, the infrastructure management is completely taken over by the cloud service provider. Amazon SageMaker, Azure ML Studio, IBM Watson Studio, good examples of that. Finally comes a new level of abstraction, which we haven't seen in the cloud-based infrastructure, is cognitive services. Here, you are not doing anything. All capabilities are already available. You don't need to build, train, infer. You only need to you don't even have to provide a sample data. You don't have to manage any infrastructure requirements. The capabilities are available directly for you. This is the equivalence of conversation assistants, the Alexas of the world, your Amazon recognition video, your Azure Compute Vision, IBM Watson text-to-speech. All these things are readily available capabilities. What you have to do is just call an API. Okay, I need to detect this image. Just call an API. You will get, with a certain confidence level, what this image is to be. Same thing with video. Same thing with sentiment analysis or text analysis. So these are called AML services or cognitive services. So as you can see, again, from moving from left to right, you had full control on the AML platforms, but you have to have a lot of investments upfront. You need to have a deep expertise. On the rightmost side, you don't need to have any expertise, but you are limited by the capabilities offered by the service providers. There are, one good news is that these cloud service providers are offering even more vertical specific capabilities, like forecast or Amazon forecast or Google Contact Center AI, which enables even you don't have, without having any data science experience, you can just consume it directly for your business use case. While by now you might have realized, having the analogy with IaaS consumption model, AN consumption model, you could visualize which is the right model for you, which is the right level of abstraction for you, and you can make a right decision on what to use it, right? This can be very easily summarized with this diagram. Key things to consider here: what is the return on investment for you? Do you want your return of investment right away, or you are willing for a long haul? What is the ease of use? How easy is it for me to get started? And then the other end of the other criteria is your flexibility requirements, right? But if you were to think about all these three metrics, you can see that for something that you want to be very easy to use, but with high returns of investments, you want to start with cognitive services. But this also provides you the least amount of flexibility. You may not have the business use case that you are looking for, but if image recognition is your business use case or video recognition is your use case, it makes sense to use those capabilities which are readily available. You don't have any upfront cost, no need of building, no need of managing any infrastructure. Just go away, just call an API, get your business case done. On the other end of the spectrum is you have a lot of control requirements. It's a very, you are trying to have a business use case which hasn't been done before, or it's a very, it provides you a competitive advantage. And in those kind of cases, you need to have full flexibility about what kind of data you use, what kind of algorithms you use, how do you optimize, what is the infrastructure that is running on, what is the GPU that you wanna train it on, what is the inference engine that you want to all kind of criteria. If you have less flexibility, if you want to have more flexibility on that, but you are willing to do a lot more work with, we're willing to wait for your returns to come in a much later stage, then, go with the AI and ML platforms. And you can see, it's kind of a moving spectrum. You can see where you can place, where you are in terms of adoption maturity, in terms of your requirements. You can pick the right consumption model for you. So this provides a very infrastructure point of view of consuming this, right? We applied an infrastructure model into consuming AI and ML technologies, and we're trying to arrive at, since you're already into some level of cloud adoption, or most of us are already in some level of cloud adoption, we can apply that model. Now we can do a little bit better, right? So earlier we talked about, how do we make use of these AI capabilities? There's some questions about what do I get started with? What is the right level of, what is the right workload for me? Those kind of questions. One way to look at is, this is how IDC classifies AI workloads, but this is something to consider, right? If you're looking at an AI application, it's used for building the AI capabilities. That's where the likes of TensorFlow or your AI as a service, ML as a service will come in, right? These are used to build an AI capability. Then comes into pre-built applications which already have some kind of AI and AI capabilities. Your conversational assistants, your AR, VR, your data analytics workloads, all these come under AI apps. They already deliver you an AI capability. But what most of the enterprises care about are what are on the top, your line of business applications. Now, they can be AI enabled. By what AI enabled, what we mean is the application that you're already using, you may not be enhancing it with AI enabled capabilities. You may not be doing anything towards infusing AI capability. The application vendor may already be doing it, most likely doing it already. So as an enterprise, you have the choice. Depending on where you want to focus your efforts on, depending on what you want to achieve, what is your business use case, you can pick one of these three options. Most likely, whether you prefer, whether you have the expertise to spend or not, it is inevitable that with more and more adoption of AI and enabled technologies, your line of business applications are most likely to be AI enhanced. If they are not already, in the next few years, they're going to be AI enhanced. And depending on your investments and your skill set requirements, you can choose to either consume them directly, or you can start from bottom. You can start using the AI and software platforms. Again, apply the same model that we discussed before, and you can find the right fit. Now comes the question of, okay, I have an AI application, I have an AI workload. Where do we place it? When I say place it, in the sense that, with the adoption of cloud, with the advent of more and more edge devices coming up, roughly speaking, you have three broad locations, right? What used to be your on-premises, that's called core. The public cloud, there is this off-premises location. And then you have the proliferation of edge devices, your workshops, your manufacturing units, your windmills, whatnot. They're all good cases of edge locations. A good rule of thumb is, depending on your use case, depending on the decision that we made, if it's a highly impactful decision that you're making, try to place it the close of where the application is running, very close to where the application is running. If it's more of historic, it's more of descriptive, more of reactive, then try to run it on the cloud. Similarly with your immediacy requirements. For example, if you have to decide whether do I need to order for a replacement of a spare part, that's more of a very impactful decision to make based on the usage pattern, based on what the previous history of ordering replacement parts. You may want to be very proactive on that. So those kind of decisions, the applications that are making those kind of decisions, you may want to run at the edge location. But if you're looking at more of, okay, what has been my previous historic, what has been the historic behavior, you don't have to run them at the edge locations. You can probably run at the cloud or core. So this is another way to look at where you have an AI workload, you have come up with what is the right model for you, but you are thinking about where to place that. Try to apply this rule of thumb. Now we discussed so far various way to consume AI and ML technologies, right? We looked at from an infrastructure, kind of applying the infrastructure model there. Let's say that you decided, let's say that you do want to run an AI application, and you have certain thought process around where you're going to run that, what kind of platforms that you're going to use. But now comes the key question of where are you going to run it? There is an infrastructure piece that is required. How do we approach that? For that, you can consider this visualization. Think like an AI plane. What here is that you have various options, various choices to make. For example, the one that we discussed so far, what is the consumption model? Then comes into where are you going to run it? Then comes into your question of your computational pieces. What kind of CPUs do you need? Do you need an accelerated hardware for that? Do you need is it okay to run with general purpose hardware? There's also a data plane. What kind of storage backend is required? Finally comes the application plane, right? Where you are writing your machine learning models, where you are writing your AI applications, and then you are using models and libraries and whatnot. But it's a very intensive slide to look at, but this helps you to visualize what are all the moving parts that are required to support an AI application. And we are trying to provide a very interoperable framework here. I will spend like 2 minutes to discuss that, because you can spend an entire hour discussing this. But the key thing to note here is that there are various moving parts, but roughly put, if you can think about it, all you carry is the application plane, right? Your LOB application, whether it is AI-enabled workload, or is an AI software platform? Ultimately, like you're thinking, an enterprise thinks in terms of what is my application? What am I going to get it? What is my business use case? What is the value? Where am I going to apply AI here? What am I going to get out of that? Then comes the tools that are help you to enable that, right? Whether it is your workflows, whether it's IDE, whether it's your framework or your models, libraries, whatnot, they come under that. So think that, and then that lot of decisions that you're making there comes with, again, the expertise, in-house expertise. What is the your propensity to that, like your .NET shop or an open source shop. So those things, those kind of decisions are important there. Then comes, your data plane. This is where, like, you're talking about your historic data, your model and training data, right? How do you sanitize that? How do you promote the data from training to inference to archive? What is the lifecycle management for that? What is the storage layer that supports that? All those key things will go under the data plane. Then comes your control plane. This is where your entire, what is the right CPU I want to use? Do I need to use accelerated hardware or not? Then comes your location. Then comes the consumption model. I kind of put it from top down. However you look at it, the recommendation here is, this gives you a basic slate to start with. Move around the pieces depending on your various choices, whether it could be, if you're an open source shop, you have all these options available for you with respective open source components, software and tools to fill that up. Similarly, you have hardware infrastructure that supports these kind of open source options. If you don't want to do this, if you're going with this ML as a service or AI as a service model, where you are leveraging on the cloud service provider, there are options, right? Everything is as a service. Your infrastructure layers on a cloud service platform. Your storage is coming from a storage service platform. And you, not only that, you also have the applications and the modeling, and all those things are also available as a service. Some of them, like ML Studio, for example, or ML Library, for an example. So this helps you, again, to think from a complete entire stack. If this is what I want to do, these are the options for me available, and let me go about picking the right thing for me. And what is the right thing for you? That is the key thing here. Based on all these things that we discussed about an AI application or AI-enabled application, lots of moving pieces, lots of decisions to make, we recommend you to go with 3 B's and 3 R's. What are 3 B's? Always business first. The reason is, 5 years ago, something was really cool. 10 years ago, something was really cool. Now something is cool, but does it really matter, right? Like, if you are going behind what is cool, that's not the right way of approaching it. For vast majority of enterprises, it is entirely fine to say that I don't need to leverage AI and ML. I know, this could be shocking for some of you, but it is possible, right? If my business use case does not require leveraging AI and ML technology, that's absolutely fine. Don't start with AI school, so I want to cross-fit my business case with that. That's the sure route for failure. Disappointments galore there. So please start with business first. Then comes your other 2 B's, buy versus build. Here is like, if there are options for you to consume something as a readily available package service with cognitive services, and you can leverage them, go for that. But if they are not available, or you have specific cases, whether it could be like, a competitive advantage, for example, or sensitive data, or lack of subject matter expertise on the cloud service provider, then go with the build approach. So buy versus build, this is a very standard, very time decision metric to follow. It is equally applicable here. Please go with buy versus build. So those are the 3 B's. 3 R's, choose the right stack for you. What is the right infrastructure layer for you? It could be open source based, it could be as a service based, whatnot. Take the decision matrix, figure out what is the right thing for you. You have already figured out what is the right consumption model, and apply the right stack for you. And once you have gone for that, try to have the right application architecture, right data architecture. It involves using right algorithms, the way you are writing your application or rewriting your application. Finally, right partnerships. Why it is important is, not all the enterprises have the necessary expertise. Wherever possible, leverage expertise. It could be the partnering with the cloud service provider in a way that consuming the readily built services, or it could be partnering with a professional service provider, a managed service provider, and helping you to build those AI-enabled applications or train you with AI applications. So remember, 3 B's, 3 R's. With that, I would like to open up for the questions.
I think we have questions, but we are almost out of time. Is there a way we can, let me check with the questions.
Absolutely. I have those questions here. AR, VR business solutions. Okay, I don't want to take too much of time. I'm happy to answer this via email. Mr. Sriram has asked these questions. So why don't I take it by email?
Okay, okay.
Thank you.
Why don't
Thank
we
you
do
for the
that? Because
opportunity.
we want
Thank you all.
next speaker, Andrew, gets his own due time. That's what we are trying to do. Thank you, Sriram. Very good presentation coming from company like IDC. You have a full understanding of it, the industry and where, who is doing. And I would myself would like to ask about multi-cloud some other time when we are when we get free time.
Thank you. My pleasure.
Okay. Thank you.
Don't close the chat window. I'm copying the questions, but I do appreciate everybody, and everybody stay safe and healthy. Thank you.
Yeah, thank you a lot. Okay, now let me just go to the speakers. Okay, now we have the next speaker. He's the Vice President of Engineering at Zillow Group. He's Andriy Lopatenko, and he leads the team responsible for the company's search and discovery engines, including search